Hello students, this is elastic physics. Today let us learn about oblique projectile and special cases. Projectile.
I showed them the answer.
Projectile motion, the trajectory of a kicked football. A body which moves in a two-dimensional plane and moving only under the influence of force of gravity is called a projectile. Examples of projectile: a cricket ball thrown by a player not rolling on the ground, an athlete taking long jump or high jump, a bomb dropped from an aeroplane flying at some height. Examples for projectile: man fired from cannon in olden days. Types of projectile. We're going to study projectile motion in two separate cases, namely oblique projectile, horizontal projectile. Now, oblique projectile, a body projected at an angle 0 degree at theta theta not equal to 90 degree and 0 degree with the horizontal and moving only under the influence of force of gravity is called an oblique projectile. Theta not equal to 90 degree and 0 degree. This is the angle theta made with the horizon. Now, horizontal projectile, a body in two-dimensional motion has uniform horizontal velocity throughout its journey, and vertical motion is similar to that of a freely falling body, then it can be considered as a horizontal projectile. For projectile, in horizontal projectile, direction velocity is constant. That is, acceleration is equal to 0. In vertical direction, acceleration is constant and equal to acceleration to gravity g. That is, A is equal to minus g. Now, MCQs for you. A body moves in two-dimensional plane in the gravitational field of the Earth is called a number A, horizontal path, number B, vertical path, number C, hyperbola, number T, projectile. So your answer is projectile, number D. Now question number 2. A body projected at an angle theta with the horizontal and moving only under the influence of force of gravity is called as number A, horizontal projectile, oblique projectile, only projectile, number D, both A and C. So your answer is oblique projectile. The trajectory of a projectile is a parabola. See the diagram, see the graph. It's along the x-axis. This is the y-axis, and it is thrown at an angle, thrown at a velocity u. So this path is a parabola. Your theta is less than 90 degree. So it has been made to u sine theta along the y-axis and u cos theta along the x-axis. The horizontal component is u cos theta and the vertical component is u sine theta. It is resolved into two components, Vx and Vy at a particular point. So this V has made an angle alpha with Vx. So the position is P. So it is u cos theta, Vx, Vy. So this V, the position. Now this is the maximum height h attained. This is the horizontal range R where it reaches the ground. Consider a body projected into air with an initial velocity u, making an angle theta with the horizontal. Initial velocity u can be resolved into two rectangular components. Horizontal motion with zero acceleration, ux is equal to u cos theta. So it remains constant throughout the journey because your acceleration is zero. Vertical motion with constant downward acceleration, uy is u sine theta, varies with time. Let the projectile be at the position P, x, y coordinates after time t. X and y are the horizontal and vertical displacements after time t. Along the horizontal direction, horizontal displacement, x is equal to u cos theta into t. There is no acceleration. It's speed into time. From there, I get t as x by u cos theta. This is equation 1. Along the vertical direction, vertical displacement y is equal to u sine theta t minus half gt square. So we followed s is equal to ut plus half gt square formula. This is equation 2. Now substituting equation 1 in equation 2, y is equal to u sine theta, x by u cos theta. We put the value of t from equation 1 minus half g x by u cos theta whole square. So we have taken t is equal to x by u cos theta from equation 1. So it becomes y is equal to tan theta x minus g x square by 2u square cos square theta. So it represents an equation of a parabola y is equal to ax minus bx square, where a is tan theta and b is g by 2u square cos square theta. So this is an equation for a parabola. The trajectory of the projectile is a parabola. Maximum height h of a projectile. The maximum vertical distance traveled by the projectile before its vertical component of velocity becomes zero is called maximum height. Along vertical direction, initial velocity uy is equal to u sine theta. Final velocity vy is equal to zero because it has reached the maximum height. Acceleration ay is equal to minus zero because it is ascending. Distance traveled s is equal to h. From the equation, v square minus u square is equal to 2as. So you put the value of v as 0 because it has reached the maximum height, 0 minus u square sine square theta, replacing u by u sine theta, minus 2gh. H is the maximum height. So from here we get the value of h as u square sine square theta by 2g. This is the formula for this. At the maximum height, velocity of the projectile is u cos theta along the horizontal. At the maximum height, the acceleration of the projected body is equal to the acceleration due to gravity g plus g acts vertically downwards. At the maximum height, the angle between velocity and acceleration of the projectile is 90 degree. Time of ascent, TA, of a projectile. Time taken to reach maximum height is called time of ascent. Let time be denoted by TA. At the maximum height, the velocity along vertical is 0, that is Vy is equal to 0, and from equation Vy is equal to u sin theta minus gta is equal to 0 because your final velocity is 0. So my time of ascent is equal to u sin theta by g. So we have taken it as equation A. So time of flight, capital T. The total time the projectile takes to reach the same horizontal plane of projection from where it has started, the same plane, is called the time of flight. This can be obtained by substituting y is equal to 0 and small t is equal to capital T. Capital T is the time of flight. In y is equal to u sin theta capital T minus half gt square is equal to 0. From there we get the total time or the time of flight capital T to u sin theta by g. This is equation B. Comparing equation A and B, we get capital T is equal to 2TA. Time of flight is equal to twice the time of ascent. Why is the time of flight double the time taken to reach the maximum height of a projectile? Because it is due to the symmetry of the parabolic path. Not time of flight capital T is equal to time of ascent plus time of descent. T is equal to capital T is equal to TA plus TD. Capital T is equal to u sin theta by g plus u sin theta by g because time of ascent and time of descent are same. So capital T is equal to 2 sin theta by g. Horizontal range R of a projectile. The maximum horizontal distance traveled by the projectile from the point of projection during the time of flight is called horizontal range. This is the horizontal range R, and this is the maximum height attained H, capital H. Along the horizontal direction, initial velocity ux is equal to u cos theta, acceleration x is equal to 0, distance traveled s is equal to capital R, and time taken small t is equal to capital T. From s is equal to ut plus half at square, R is equal to u cos theta is equal to u cos theta into capital T. But capital T is equal to 2 sin theta by g, we already know that. So therefore capital R, horizontal range, is equal to u cos theta into 2u sin theta by g. That makes R is equal to 2u square cos theta sin theta by g is equal to u square sin 2 theta, because 2 cos theta sin theta is sin 2 theta. So u square sin 2 theta by g is R. Note, for a given value of projection value u, R is maximum when 2 theta is equal to 90 degree, that is theta is equal to 45 degree. So maximum horizontal range is, or max is equal to u square by g. Therefore sin 90 is equal to 1. Not for a given speed of projection, u, the ranges are equal for angles 90 minus theta of theta. So theta is equal to 45 degree. Theta comma 90 minus theta be 45 degree plus alpha, 45 degree minus alpha. Thank you for today. Good night.